Welcome to this explainer. Today, we are unpacking something pretty incredible. It's called Aegis, and it's an AI-powered multi-agent system that is designed to completely revolutionize how we approach diabetes management. I mean, we're not just talking about another tracking app here. It is an actual live medical digital twin. So if you've ever found yourself wondering how we can safely integrate advanced AI into, critical life-or-death healthcare scenarios without everything going off the rails, you are absolutely in the right place.
Okay, so let's just dive right into the elephant in the room. Whenever we talk about artificial intelligence in medicine, the immediate question is always, how on earth do we prevent the AI from hallucinating? Because an AI confidently making up incorrect information when a patient's health or, honestly, their life is on the line, that is a massive problem. A large language model just guessing the wrong insulin dose isn't a quirky software bug, it's a catastrophic hazard. I mean, you really wouldn't want a creative writer doing your calculus for you, right? Well, Aegis actually solves this exact problem by heavily constraining the AI. It uses what are called agentic workflows to ensure the system doesn't guess, it calculates. When you first jump into the platform, things are kept really clean and straightforward. You've got immediate access points for patients, doctors, and administrators. But what's really interesting is the back-end setup. Aegis utilizes a dual-mode authentication model. So for quick local demonstration setups, it uses local JWT, but it's also fully built out with Auth0, which gives it that secure, industry-standard, production-ready identity management that a system like this actually needs. So once you're actually logged in, the entire platform is driven by strict role-based access control. This makes sure everyone gets a tailored and, more importantly, a secure experience. A patient gets a dashboard that is focused purely on their own live telemetry and personal simulations. A clinician, on the other hand, gets a much broader profile so they can monitor their specific roster of assigned patients. And then finally, you have the administrator who has oversight of the entire system's health, managing assignments and all the back-end infrastructure. And really, this kind of strict segregation of duties, it's a fundamental security requirement in literally any medical software. Now, the absolute core of this whole platform is the idea of the medical digital twin. And if you aren't familiar with that term, just think of it as a highly detailed, synthetic snapshot of a patient's current physiology. It essentially takes all the incoming data, so things like glucose readings, meals you've eaten, insulin doses, and it uses that to maintain a live state. From there, it can actually predict future medical trajectories. It is literally a virtual mirror of your metabolism running in real time. For the patient, this twin really comes to life right on their dashboard. Front and center, you have these highly dynamic metrics. For instance, a current glucose reading of 200, right next to a flashing high clinical risk level, which acts as an immediate prompt that an intervention might be needed. Then, over on the left, there's the physiological event input form. When a patient logs real-world observations, like the carbs they just ate or the insulin they took, and hits Update Twin, all that data streams directly into the virtual model to instantly recalculate their current state. But, what's actually happening behind the scenes when they click that button? Well, let's take a look under the hood. If we peel back the user interface, it reveals this incredibly sophisticated multi-agent pipeline. And this whole thing is orchestrated via a framework called LangGraph. See, Aegis doesn't just rely on one big monolithic AI model. It actually uses a whole team of highly specialized AI agents. First, we have the ingestion agent, which takes the raw data from that patient form and structures it. Then, the twin agent steps in to update the live physiological models. After that, the simulation agent runs the really complex predictive math. And finally, the explanation agent takes all those raw mathematical results and translates them into plain, understandable English. You can even see these state transitions happening in real time on the agent activity feed. It's just a beautifully coordinated workflow. All right, so this brings us right back to that hallucination problem we talked about at the very beginning. If you just ask a standard generative LLM to calculate an insulin dose, you are taking on an unacceptable amount of risk. Because at the end of the day, an LLM is basically just predicting the next most likely word. It's not actually doing hard math. Aegis solves this brilliantly by utilizing the Model Context Protocol, or MCP. What MCP does is it allows the AI agents to completely delegate the mathematical calculations to an isolated deterministic analytics server. So the AI isn't doing the math at all. It's just handing the variables over to a calculator and then waiting for the hard, mathematically proven result to come back. This constraint completely prevents those dangerous AI hallucinations when it comes to dosage logic. It's a total game changer. And because we have that calculator-backed safety net in place, we can actually start asking the system hypothetical questions with total confidence. Imagine you're a diabetic patient. You're looking at a high glucose reading, and you ask, hey, what if I adjust my insulin dose by 2 units before I eat? That is a very real, very high-stakes decision that patients literally have to make every single day.
And that is exactly what the simulation panel is designed for. That crucial what-if modeling. The user just inputs their proposed change, like, say, adding those 2 units of insulin, and clicks Run Simulation. The simulation agent takes over, routes all the math safely through that MCP protocol we talked about, and then it returns a predicted 6-hour glucose trajectory, right alongside a really clear natural language summary. It completely empowers the patient. It lets them test drive their insulin strategy safely, well before they ever actually take an injection.
Now, zooming out to the macro view for a second, clinicians use the doctor portal to monitor the twin states of all their assigned patients at a glance. This lets them immediately spot who might need an intervention or maybe a tweak to their care plan. Meanwhile, administrators are using their console to oversee the overall system health. They securely manage the database linkages between specific doctors and patients, which ensures the entire operation is just running incredibly smoothly behind the scenes. Of course, to run all these simultaneous multi-agent workflows without skipping a beat, Aegis requires a seriously resilient backend. For persistent patient data, it relies on PostgreSQL. But for that real-time, high-speed telemetry, it leverages a Redis 7 cache. And when you combine that with RabbitMQ3 for the rapid agent-to-agent messaging, you get an architecture that guarantees the system won't just stall out or crash when a critical insulin calculation is urgently needed. So we'll wrap things up today with a really critical paradigm shift. Aegis is profoundly impressive, for sure, but it is not a medical oracle. It is absolutely not designed to diagnose disease or to autonomously administer insulin. Instead, it is a heavily constrained, calculator-backed AI orchestration engine. By utilizing tools like LangGraph to organize the agents and the model context protocol to strictly enforce mathematical safety, Aegis shows us exactly how AI can be integrated into healthcare responsibly. It's a powerful advisory tool that still requires human clinician review, but it dramatically enhances the data available to both the patient and the doctor. So, the big question I want to leave you with today is, how many other fields of critical safety could be completely transformed by replacing open-ended AI with this kind of constrained agentic orchestration? Something to think about. Thank you so much for joining me for this explainer, and as always, keep learning.